As we come to the end of the course, I thought I'd use this chance to actually answer some of the questions you've been putting on the discussion boards and to say how much I've been enjoying the discussions and seeing how learners have been helping each other, how you've been interacting with our mentors, and how you've been really enjoying the material we've put together for you. So a lot of the discussion has been about deep sea mining, and one of the posts I've already put up is a link to this report which we published this year. So I was a member of the working group that spent quite a lot of time over the last 6 months reviewing deep sea mining and marine genetic resources in the ocean. And this is a sort of a report of the state of the art, the state of play at the moment, both in UK waters and in the global international waters in terms of what we know about minerals in the deep ocean, what we know about marine genetic resources in the deep ocean, and what the implications are for exploiting these and exploring for them in the future. But to answer some of your specific questions, I think a lot of you are obviously very concerned about the implications of exploiting minerals in the deep ocean and the impact this might have on these unique ecosystems we're only just beginning to understand the diversity of in the deep ocean. And we all share these concerns. And as scientists, what we've tried to do in this report is to have an evidence-based discussion about what we know about the likely implications of mining in the deep ocean. So one of the things we know is that the ecosystems associated with these deep sea deposits are pretty unique. And while there are some commonalities between the sites, every site we go to, we still find new species of organism. And you've seen John's collector's curve, and that curve is still rising steadily as we find more and more species on the seafloor. So we're still at the exploration stage in terms of understanding deep sea biodiversity. So this tells us that we need to be really careful with these systems on the seafloor. We need to maintain them, we need to steward them, and we need to make sure they're there for the future. So the exploration licenses that are given out by the International Seabed Authority are pretty prescriptive in terms of the type of baseline survey that has to be done, the type of data that has to be collected, and the evidence that has to be provided by the exploration team in terms of assessing, doing an impact assessment of any likely mining on the seafloor. And we're still at the exploration stage. We haven't moved to exploitation at all in international waters. Now, it turns out that I think from the studies that have been done, the most likely impacts are going to come from the plumes of sediment that are disturbed by the mining activity. These plumes will rise up in the water column. They may well contain significant toxic material. That material will rain down onto the seafloor, smothering what's on the seafloor and maybe causing toxicity to the organisms that are there. So we don't really know what extent the impact of mining will have on the seafloor at all in terms of the ecosystem impact, or in terms of the impact and disturbance of material through the ocean, how far those plumes will go, how far those particles will go. So we're doing scientific experiments at the moment in situ in certain areas to actually understand the likely impact. And we as scientists can contribute to this understanding and to these baseline surveys. So that brings us on to another question that's really interesting, which is how long does it take to mine out a particular deposit, and how long does it take to recover in terms of growing back the deposit and growing back the ecosystem that we might disturb? And again, I'm afraid to say we really don't know, but we do know sort of ballpark formation rates. So hydrothermal vents form relatively quickly. So the chimneys can grow at maybe meters per year, but those manganese nodules that we've talked about grow incredibly slowly. They take millions of years to grow to their sort of golf ball size, their tennis ball size. So the rate of growth of deposits is very, very variable, from meters per year to millimeters per millions of years. The ecosystems associated with these deposits are really, really different. And so they're specific to the deposit. And we know that a lot of the transmission of the larvae goes through the water column and they settle on the deposits. They'll settle on newly formed hydrothermal vents, and they'll settle on newly formed manganese crusts. So with enough time, natural settlement will actually allow the ecosystems to recover, but we have no real idea about the actual rate of that recovery. We know that all processes occur incredibly slowly in the deep ocean, so the likely recovery rate of a specific deposit is likely to be very, very slow. An interesting question from one of the learners has been about landlocked countries. And it turns out that if a landlocked country is a signatory to UNCLOS, remember that's the United Nations Convention on the Law of the Sea, then they have rights. They have rights of passage through the countries between them and the ocean and the territorial waters of that country. So being a signatory to UNCLOS gives them specific rights. And remember that the minerals on the deep sea floor are there for the heritage of all mankind, and so the benefits are shared, the revenue streams are shared, and any other things that come from our exploitation of these mineral resources in the area, as we call it, are shared amongst all of the signatories of UNCLOS. If they're not a signatory of UNCLOS, and several countries aren't, there's something like 42 countries that aren't signatories of UNCLOS, then I'm afraid they have to negotiate access separately. And so actually signing up to these international conventions gives you access to the revenues from any likely exploitation of minerals from the seafloor. So a lot of you have been asking, what can you do? What can you do to make sure the future of the oceans is going to be safe and maintained? And so there's individual action. There are quite a lot of individual consultations that you can contribute to, but they're quite technical. But you might want to use the voices of other people. You can use the voices of your Member of Parliament. You can use the voices of the NGOs that you're associated with. You can use the voices of your professional societies if you're a graduate from a specific programme. And so collectively, often we can get our voices heard a lot more readily. We've talked about DOSI, the Deep Ocean Stewardship Initiative, and again that is a forum whereby you can contribute to the discussion, and DOSI has a voice and it has a seat at the table for discussions, so you could connect with that organisation if you felt that was a way to get your voice heard. So we really welcome you to join our community of ocean scientists, whatever your background. And you've certainly, through your discussion on this MOOC, you've shown us that you understand and can bring a lot of valuable input to the discussions, and we urge that you continue to do this into the future. You'll have noticed that we've got new material in this version of the MOOC that has come from our partners Nelson Mandela University, who are based in Port Elizabeth in South Africa. And we're finding that this partnership working with people from various countries is actually really increasing our range of our impact globally. So this partnership is funded through what's called the Newton Fund, and the Newton Fund is part of the UK funding for official development overseas. And that funding is specifically for partnership working to help partners develop in terms of their social responsibility and their environmental responsibility locally and their economic development. And so South Africa is one of our preferred partners in this case, and Port Elizabeth is an area where we think we can make a real difference by working together. But partnership working isn't just with other universities and other countries funded by the Newton Fund. Partnership working is with all sorts of areas. We partner with industry, we partner with overseas aid development areas, we partner with NGOs, we partner with other universities, we partner with other funding councils. And it's through these different ways of working that we can actually collectively study the oceans, study the deep oceans, and make a difference to with policy interventions and actually the future of this planet. Looking forwards, we're going to have to update the MOOC material because this area is moving really fast. A lot of you have picked up on how the legislation for banning plastic bags in the UK has led to massive decreases in single-use plastic bag in the UK, and thereby less plastic going into landfill, less plastic going into the ocean. But that is only the start. So into the future, we'll be looking in this in a lot more detail. The impact of mining minerals in the ocean, again, is going to be a hot topic for the next decade or so, I'm sure. You'll have seen the commitment from the UK government to move to electric cars in the future. They've actually committed to do this. To do this, we're going to have a significantly increased amount of, in particular, things like cobalt to deliver the electric car technology that we require to actually change our usage. And at the moment, battery powers need a significant amount of cobalt. So until we change that, we're going to have to find cobalt resources either from land-based resources or potentially from what we know, the manganese nodules and the manganese crusts in the ocean. So we need to contribute to that discussion. We need to understand the potential pros and cons of moving to electrical cars, but are increasing critical metals to enable us to do that. And we need to understand the balance and provide the evidence so that we can actually make the right policy decisions to actually sustain our future. So I want to finish by saying thank you for coming with us. It's been great having you on this journey for the last 4 weeks. I've really enjoyed your contributions to the discussion boards, and our mentors have really enjoyed answering your questions and seeing the discussions develop. Hopefully some of you will come back for the next run. We're going to have new material, as I've discussed, in the next run. We're going to bring in some new thoughts and new ideas as the things we're discussing develop. Our mentors will be back for the next run, and so you're very welcome to join us. So thank you for contributing, and thank you for all your time, and do join us again.